All right. Good morning, everybody. Introductions were made, so I will not repeat myself. I called or subtitled my presentation as a low-hanging fruit. And what I'll be talking about is how we can decrease the footprint, carbon footprint or carbon-like footprint in the operating room. And it is a low-hanging fruit for all of us anesthesiologists, and it looks beautiful and juicy and sweet. And not many of us still grab it, which is a problem that probably will be repeated in our presentations here. Awesome. So I will not waste time on the same disclaimers and CME information that you guys have. Learning objectives, how operating room contribute to healthcare greenhouse gas emissions, and that will be my part. Brian was talking about solids and fluids. We will list at least two means of decreasing our contributions, and again, Brian already addressed some of this. Three actions that Montana providers and healthcare facilities could take to reduce greenhouse gas emissions, and that will be featured in my presentation quite intensely. Environment, as much as we love it, it's the nature that we want to preserve versus the local reality. I lived here in Billings between 2017 and 2020, lived in a nice modern apartment complex, which is called Avenue C. And I was coming after 20 years living in Seattle, and Seattle is very proper in trying to recycle and reuse and so on and so forth. So of course I wanted to proceed with the same manner. Well, two things that the big hamper that was in the courtyard of the facility was, for recycling, there were only two items, which is paper and cardboard, and only aluminum cans, not even metal cans, no glass, no plastic, nothing else. I have no idea to what extent the situation in Seattle has changed since 2020, but we are bound by whatever we can do, even if with the best intentions. And the second factor, obviously, is human. So kudos to the organizers, because it takes overzealous bulldogs, I would say, to exert change. And it's very difficult. So thank you for persistence, Byrons. This is my household, and this is the cubby, lids taken off, showing how it works in Vancouver, British Columbia. So I have 4 different compartments. One is for all packages, so plastic, metal, glass goes all in one. It's being sorted in the facility. This is for paper. Cardboard is separate. This is for bio, and this is trash, mostly our grandson's diapers at this point. So I've checked actually what happens to those things. So bio 100% goes into being recycled and made into a turf. Paper 100% recycled, going into a paper pulp and reused. Plastic and metal pretty much 100% recycled. Plastic in part recycled, in part incinerated. Here a little byline, Sweden is actually importing trash from many countries in Europe and using it as a fuel. They have a process that apparently puts very little of toxic substances from burning of the trash into the chimney. I don't know which is better, incinerating the plastic or incinerating coal. Probably plastic is better because it's part of things that we throw away. So is it possible to be a little more conscious of what to do and how to do? Yes. Fast forward to the operating room. So these are two heroes of today's speech, which is a sevoflurane and its vaporizer, and desflurane and its vaporizer. These are two liquids that are being turned into vapors. So it's theoretically not the gas, it's a vapor rather than gas. We are using one of the gas that is being delivered to us in the liquid form, but in that enters the gaseous form, and that's nitrous oxide, and we talk about it as well. None of them are good actors, I mean, beautiful actors that allow us to take care of you, put you asleep safely, and more importantly, wake you up quite quickly after the surgery is done. But they are not without untoward effects that we would like to avoid. So busy slide, but I want you to look at the three actors that we will be talking about. Nitrous oxide, it lives in atmosphere for 114 years. The molecule of CO2 that we talk about so much lives in atmosphere for about 5 years. That's the most oft cited life cycle of CO2 molecule that I have seen. So this wonderful anesthetic that since 1846 and in wide use, much less wide nowadays when we have sevoflurane and desflurane and isoflurane, but still in use, lives in atmosphere for 114 years. Now, what is the 20-year time horizon for global warming potential for this agent? It's 289, whereas index 1 is a CO2. So this not only lives 50 times longer than CO2, but has almost 300